So first of all, welcome everybody here, actually to my home office. It's actually not the headquarter because Accenture doesn't have a thing like a headquarter, yeah. But it's one of our big offices here, so I'm very happy that you are all here today. And actually the first topic and the keynote that I was asked to give here today is thinking a little bit about how big data, and our topic is Datanauts today, how big data is actually fueling the digital economy. So there are two buzzwords, yeah, the big data and the digital economy. How do they actually fit together? And let me start a little bit with trying to define what we mean with big data. So you certainly know the definitions that are around. They are in the literature, and especially in Germany here, there is the Bitkom that has made this definition of thinking about what is big about big data. Is it just the volume? Yeah? So it's actually certainly about the volume. Yeah? So big data means lots of megabytes, lots of gigabytes, lots of petabytes of volume of data actually. But that's not the only feature that we have to think about. There's also the velocity, yeah? So the kind of speed with which we have to get access to the data, with which we have to create meaning out of the data in order to come to an answer to actually use the data. Yeah? So if you are using data to control your self-driving car, you actually don't want to wait for a couple of seconds until the response comes back, because otherwise the dog that's just crossing the road might be gone already in one way or the other. Yeah. So next thing is certainly also about variety. In the last 2 or 3 decades where we actually do IT, especially in an enterprise environment, and we are mainly focused around structured data. So we are looking at tabular data. Very much of that is coming out of finance information that we're looking at, out of procurement information. So we're looking at customer data, product data, account data, and things like that. Very structured, can also be done in a table. And we use the paradigm of the relational database in order to get along with that. But there's so much additional data, other structures of data that is around. We have pictures, we have sound, we have video, we have sensory data that we can use. And all of this data also can actually make a lot of sense in this context. So the variety of data is certainly important. And finally, of course, what everybody is interested in, what's it all about? Yeah? So does it generate any value for the companies? Does it generate really value in terms of, is there any return on investment, as they like to say, or can I actually solve interesting problems for that? Yeah? And if you look at these things, yeah, it's not only about these features of big data, it's also what are kind of the requirements that come up with it. And for the volume, of course, it's first of all the storage. Yeah? So we need to somehow store all that stuff. For the velocity, it's in the end the computational power that we need. For the variety, it has very much to do with new ways of recording data and having sensory data as an input. The Internet of Things will have a big impact on this one, so we're getting new types of data and much more data around objects and environment in our world. And finally, the value is about what kind of decisions can I make? Can I really change the world with doing these kind of things? So that's a little bit the definition of what is big data. And it's really an explosion. I just brought you two looking forward statements from IDC, actually. The first one was made in 2011. They said between 2009 and 2020, there will be a factor of 44 growing into, I think it was 35 zettabytes, enormous amount of number. And now actually only last year they repeated it for the last time. Now they already say in 2020 it will be 44 zettabytes. And I'm pretty sure if we do this next year, the number will be even bigger. Yeah? So it's not only a big growth that is being predicted, but even that growth is growing while we go. So the amount of data that we're getting is actually exploding to a large extent. Luckily, we have a couple of means that we can actually put against this load, this tsunami of data. So if you look at availability of computing platforms today, you have platforms like in the CERN, where my colleague Vincenzo later will talk about that a little bit more. But you also have NASA, for instance, that can harness quite a big chunk of, like I think it was almost 4 petaflops in order to do calculations. But also commercial solutions like in the Hadoop space for Yahoo, for instance, are already calling for really petabyte-sized data that you bring together and actually handle. And it becomes easier and easier. And this is to a large extent, Hello. Due to this happy guy, Gordon Moore, that actually created his law, which was actually only meant as a little look back in '65 when he issued that on the last 15 years on how the performance of computers actually have performed, and he found that approximately every 18 months the amount of computational power that is available for $1,000 is doubling. Yeah? And it's actually not 18, it's maybe 20, but you can see the law is still in place. It's just turned 15, yeah, so we had a little bit of press coverage around that a couple of weeks ago, and it just and it's still at work. So we're still seeing that we're getting more and more computational power, and this is actually enabling us to actually tackle the problems and use all of the data that is exploding, that we can actually hopefully turn into insights and use in a useful way. And to a large extent, the idea of TEDx Datanauts is around trying to find new ways, find new ideas to actually tackle this data and use all the technology that is available today. So what is the digital economy about? So we know big data, and most of you might have heard one or the other definition around that. But what is actually digital economy? And I thought maybe we start with what is not the digital economy. So what's the physical economy about? And if we look back in time, what we did in the past, it started with a craft. Yeah? So in the past, like until the early 1800s, yeah, you could go up to a craftsman or a craftswoman and actually say, this is exactly what I want to have, and then he or she would go about it and actually create it, and then you had a product. Yeah? And whatever you wanted to have, this was basically the way it was produced. There was a little bit of division of labor already, but in the end, you could exactly say, this is how I want it, and the amount of time that you needed in order to do it was approximately the same all the time. Yeah? This fundamentally changed when we started to have the idea of industrialization. So as you all know, with the advent of the steam engine in the first half of the 19th century, suddenly we had a lot of power available, a lot of physical power available, and now we could start to produce things in a different way. And the main thing that changed here from the craft to the industry was standardization. Yeah? So instead of having a unique object every time, you now have a lot of objects, but they are all the same. Yeah? So we had to come up with the idea of how do we actually make this better, to make this object, make these goods available to even more people. And the standardization obviously had quite a lot with it. But the main theme, and this actually did not stop until today, the main theme in production is that you want to run down the marginal cost, as economists say. Yeah? So you want to produce even more of the same thing for less and less money, because whenever you use physical resources, yeah, you have to, if it's labor or if it's energy or actually the raw materials that you put in, yeah, you have to think about how to run down the cost for it, and this is what is driving the physical economy, and this is where also the biggest difference is to the digital economy, because digital economy means intangible goods. Yeah, so it's not the physical object. Yeah? It's the song, it's the music that you're listening to. It's a digital book that you're reading. It might be the pictures that you have created or the videos that you're looking at. Yeah? So this is essentially, they are intangible goods. Yeah? They are, you could call them content, but in the end, of course, and this is the link where we're getting to, it's actually data. Yeah? So the digital economy that we're talking about is talking about data as a content and as an economic good. And these goods are governed by completely different rules. Essentially, copying and multiplying them and communicating since the advent of the internet is basically for free. Therefore, many economists call the digital economy a zero marginal cost economy, yeah? Or economy of abundance sometimes. Yeah? So because all the rules that govern the physical economy do not apply here. So the problem is somewhere else. Yeah? So it's not copying the stuff. Interestingly, when we started with that, and software, for instance, is of course a very intangible good, a very digital good, sheer definition of it. But even in the beginnings, if you remember back in the 90s, we started with software tied to a physical good, because the whole economy was used to actually sell these physical goods. You get them SKU, and you know exactly how many you have sold in terms of the of the diskettes or the CDs. That's how it started. Yeah? Then in the 2000s, it started to get away from this a little bit when the internet started to be the platform where I could actually have data, and also the open source community started to kick in and actually say there are different ways to actually create software and maybe also to distribute it. And so we eventually ended up in our current time where actually open source plays a very important role, where also the ability to distribute this via the internet is very important. We have things like software as a service and platform as a service, where we can build software in a completely new way. And we started to have this idea of the apps, yeah, which are all founded on a very strong platform, but essentially the app itself is content and can be created relatively cheap and relatively quickly. And therefore, I also wanted to introduce a little bit of this idea of the digital architecture. So the digital economy is actually based or needs two things to work. It needs a platform where the digital goods can actually be created and be traded on. And of course, it needs lots of ideas that in the end will be represented by apps or by the content that come on top of it. Yeah? So have these two elements of the digital architecture in mind. So, and the important feature of the platform is that it provides elements that can be recombined. Yeah? Think about it as Lego bricks. Lego bricks might seem very simple, but it's exactly that simplicity that makes it so powerful. You can recombine it in all different ways, and of course,